From our lessons on seed morphology and anatomy, we will now move our discussion to seed chemistry and composition. Seeds are composed of various reserves in the form of carbohydrates, lipids, proteins, vitamins, and minerals. Like morphoanatomy, the chemical composition of seeds is also influenced by the genetics of the plant, as well as the environment under which the seeds develop. We will discuss all about the basic composition of seed reserves and factors affecting the chemistry of the seed. But before that, let us first establish the importance or relevance of understanding the chemistry of the seed. Seeds are important sources of food and feed. In fact, more than 75% of dry matter consumed by humans come from cereal grains and about 6% are from leguminous seeds. The U.S. Department of Agriculture even recommends the intake of 6 to 11 servings of cereals or cereal products a day. So if you are fond of eating bread or pasta or cereals, you should know that those foods are processed from cereal grains. For the health junkies who are averse to consuming too much carbohydrates, seeds are your friend because you get a lot of nutrition from them, from proteins to good fats, as well as vitamins and minerals. Given the amount of seed-derived food we eat, it only makes sense that we should know the chemical composition of seeds as a way to know what we are putting in our bodies. For food manufacturers, it also helps to know the chemical composition of seeds so they can deliver better products to consumers like us. Let's take, for example, the bread that you eat every day. Different people are going to have different preferences for bread texture. Some people might prefer the usual slice of white bread for their sandwiches, while some may prefer a chewy bread like the baguette. Take a look at the pictures of bread slices in this panel. The first one under A is compact, and by compact I mean the bread did not rise or expand during baking. Bread B is well expanded, while bread C is slightly overexpanded, as you can see in its bigger size compared to bread B. If you look more closely, you will also see holes in bread C, right here. Believe it or not, these differences in the ability of the bread to rise is determined by the chemical composition of wheat seeds used to prepare the flour that is in turn used to make the bread. Wheat seeds are composed of carbohydrates, proteins, lipids, vitamins, and minerals. The proteins are of different types, but about 50% of the proteins in wheat seeds are made up of prolamines and glutenins. These proteins are important in how the bread will rise during baking. To make the dough that will be baked into bread, water is added to the wheat flour. Of course, other important components like yeast is also added. Now, when the prolamines and glutenins in the flour come in contact with water, they bind together to form gluten. Gluten forms a protein network. This protein network is like a net that traps the carbon dioxide produced by the fermenting yeast. The trapped carbon dioxide in the gluten network is what makes the bread rise during baking. Knowing that the amount of prolamine and glutenin proteins affect the texture of the bread, bakers generally will use wheat flour containing 11 to 13% proteins. Now, if you want to bake a cake, that is a different story. You're going to have to use flour with lower content of prolamines and glutenins, so your cake does not expand unnecessarily like bread. Beer is another good example to illustrate how the chemical composition of seeds affect food products. Beers can be made from cereals like hops, rye, and barley. Barley seeds are composed largely of carbohydrates, although they also contain proteins, lipids, vitamins, and minerals. One class of carbohydrates in barley seeds is known as beta-glucan. During high pressure or high temperature filtration of beers, beta-glucan particles can pass through the filters and remain in the final beer product. When the beer is chilled, the beta-glucan form gelatinous precipitates, making your beer hazy. Now, depending on beer preference, meaning some may want their beers clear or hazy like the Belgians, producers can choose to use seeds of barley with lower levels of beta-glucan or may use seeds of a different cereal other than barley to make beer. Not all seed-derived foods are created equal, and we have to balance our intake of these seeds because they directly affect our health, much like they affect the health of animals that are fed seed products. Let's use beta-glucan again as an example. Beta-glucan is a carbohydrate component of many cereals like barley and oat, and it is known to reduce cholesterol levels. When ingested, beta-glucan forms a gel-like structure that binds the cholesterol from the blood as well as the bile acids produced by the liver from blood cholesterol. Once bound by beta-glucan, cholesterol is prevented from being reabsorbed in the body and is excreted instead. So make sure you reach out for your cereals in the morning to maintain low cholesterol levels. Having said that, make sure that there is also a variety in the seed-derived products you ingest, because not doing so can have negative effects on your body. A good, although extreme example of the negative effects of having a very limited range of food is the historical outbreak of pellagra in Europe between 750 and 1850. Close to the mid-70s, corn was brought to Europe from America. Before long, it became the staple food of poor people in many areas bordering the Mediterranean. Alongside the establishment of corn as a staple is the occurrence of a skin disease known as pellagra. Pellagra is characterized by the gloves and stocking appearance of the hands and feet, as you can see in the picture in the left. This condition has been associated with diets that are based chiefly on corn and proteins containing inadequate amounts of tryptophan. Tryptophan is one of the 10 essential amino acids that the body uses to manufacture new proteins. Essential amino acids are those that are not synthesized in the body and need to be consumed through the diet. By not putting variety in your food, you might be missing out on the essential amino acids needed by the body to function properly. Aside from being important sources of food and feed, and therefore having a direct effect on human and animal health, seeds are also important sources of medicine and drugs, as well as raw materials for various industrial purposes. The starch component of seeds, for example, can be used as adhesive or glue in paper making or bookbinding. It can be used to starch clothes, make biodegradable packing materials, or even used as a substitute for talcum powder. The lipids, on the other hand, can be processed into various products like soaps, essential oils, motor oil, car wax, and moisturizers. For the plant, the chemical composition of the seed itself constitutes the food supply that will be used by the seed during germination and even during the very early stages of seedling establishment. Our lessons on seed chemistry and composition will be in the context of their biological role in seed germination and longevity, as well as seedling vigor. In summary, seeds contain reserved food supplies in the form of carbohydrates, lipids, proteins, vitamins, and minerals. These chemical components of the seed determines its germination ability, seedling vigor, and longevity. Aside from their biological functions, the chemistry and composition of a seed also determine its practical use as food, feed, medicine, and raw materials for industrial purposes.